Today I'm presenting my Amazon sentiment review analysis. This is for my final project of my NLP class. I used NLTK, Naivebayes and LSTM model to do the sentiment analysis. So today I'll be talking about overview of my project. I'll also talk about my data set. I'll also talk about how I did the pre-processing, model architecture. I'll show you my word clouds, how I did the model training, and I'll show you the results of my naive bias and LSTM model trainings. Um, I'll show you my shipping review, like a special analysis of my shipping reviews. I'll also show you analysis of review of length distribution and also of the duplicate reviews, and then I'll draw some conclusions from that. Um, let's go over the overview. So the objective of this project was to classify sentiment of the Amazon reviews. Let's go over the flowchart of how my project functions. So first of all, I loaded the raw text files and converted into structured CSV files with columns for labels, titles, and reviews. Let me show you that. Mm. So here is how I converted from text to CSV. It was in .bz2. So there is label, title, and then review. So the reason for that was to make a structured data set that's easier to manipulate and analyze. And then I shuffle the data set. I shuffle the rows of the training and testing data set to remove bias, so that you know if there are a lot of positive reviews first, then the model will train accordingly and give you a biased result. So it was to eliminate that. I did a basic analysis of like label counts and all, uh, to get a basic understanding of the data set. And then I also did pre-processing. So for that, I used cleaning techniques, like I converted reviews to lowercase, and then I used tokenization. Uh, so I tokenized the sentences into words. Um, I also removed stop words, and unwanted tokens. So basically, like punctuations and everything. So punctuations fall into the stop words, and let's talk about feature engineering. So I also did lemmatization. That's basically like normalization of the word. So if you have a word, let's say running, I normalized into run, so that will capture more linguistic features. Um, and now let's talk about hypothesis validation. I compared review lengths of the I compared average review lengths of positive versus negative reviews. I also checked for mentions of shipping and their correlation with sentiment. I also identified duplicate and potential fake reviews. This was done so that it provides a insight of the data set. Um, and then for sentiment analysis, I used naive bias. So that was for a baseline for comparison with our deep learning model. So I use LSTM for our deep learning model. This is our main sentiment analysis model. I'll show you how all about the model later on. And then I evaluated metrics like precision, recall, F1 score, and accuracy. um, this is done to like just show the model's effectiveness and compare So this is our dataset overview. We had 360,000 total reviews. Positive and negative reviews are pretty similar. Um, Almost same. So let me show you the review of the length distribution. Um, so as we can see here, this is for positive reviews and this is for negative reviews. Um, so negative reviews are slightly longer. It's 423 characters than positive reviews, which are only 390 characters. 423 and 390. So both categories have pretty similar standard deviation, which means uh, the spread of the length is very comparable. Um, the shortest review for positive review is 27 characters long, and for the negative review, it's 39 characters long. Both characters have pretty similar maximum length. It's 1012 and 11, so just one character difference. Negative reviews have higher quartile values, and this means that they are basically in general longer. Um, so this was the review of that. Let's talk about sipping analysis hypothesis. So label 1 is for review, so the negative reviews, and label 2 is the positive reviews. This was from my code. This is how I labeled it. So the key findings from this table, we can look at this. So this is for the reviews that do not mention shipping. So we can see that positive reviews make up to 50.26, 50.26, and negative reviews make up to 49.74. And we can see that uh, on the one that mentions shipping, on the reviews that mention shipping, the positive reviews are much lesser, so just 44.9%, and the negative reviews is much higher, that's 55.10%. So we can conclude that reviews that mention shipping are more likely to be negative. um, so the possible reasons that I concluded was customers may mention shipping when delays, damages, or issues occur, leading to negative feedback. Um, Now, let's see our duplicate reviews. So, I have identified duplicate reviews in the training dataset. This was done with duplicated method in pandas. Why did I do that? It was just to eliminate biases in model training, which can lead to misleading evaluation matrix, and also it can also decrease data quality. So I dropped it by using this code. um, yeah, that's we don't really have a high number of duplicate reviews, though it's just 59. uh, Now this is our word cloud. This is positive reviews word cloud. These are like the most commonly used. This is negative reviews word cloud. So for naive bias, so I use Naivebayes as baseline to quickly classify reviews and establish a performance benchmark. It worked well for simple analysis but struggled with complex pattern. And then I used LSTM, which allowed me to capture the sequential nature of text and provide significantly better accuracy. As we can see, the accuracy on this is 90%, and this is just 82%, so it is much significantly higher. um, so talking about LSTM, um, for the LSTM I used three layers. It was embedding layer, LSTM layers, and dense layer with dropout. Hyperparameters were maximum words 20,000, maximum this. And then the training process was I used 10 epochs on the batch size 64 for every epoch, and validation split was 20%. So the class 0 is for negative reviews and class 1 is for positive reviews. um, we can see that oh nope, let's look at the code for this and then I'll explain it to you. This is to convert text to CSV. um, it was in .bz2 file, and then this is title label. um, so all the infos. Where's the LSTM? Okay, so this is how I trained it. Um, yeah, so we can see that it went pretty smooth. Mm. I also displayed random samples from positive and negative reviews just to see how it looked like. Review the dataset. This is I have more of these over here. Um, so review of length. This is all my code. So yeah, that was all for today. Um, in conclusion, the LSTM model worked much better than the Naivebayes, but Naivebayes was much simpler and it was great for the simple things. That is all for today. Thank you so much for watching. Bye.